In this video, we will learn the energy band model for the three operating modes in the MOS capacitor. In the previous video, we have already seen what happens when we increase the VG. When we increase the VG or when we change the VG, the MOS cap will have three different modes. Okay, when the VG is less than 0 or negative, okay, when the gate is negative, it will attract the holes from the bodies. So the holes will be accumulated at the surface. So we call this accumulation. When it's positive, the gate will become positive. So it will repel the holes from the surface. So the surface will be depleted from the hole. When it's very positive, okay, more than the threshold voltage, it will not only repel, but it will start attracting the minority electrons from the body. Okay, the body is p-type. The majority carrier is hole, minority is electron. It will attract the minority electrons from the body to the surface. So the surface will become n-type. So we call this inversion. Okay, we inverted from p to n. Now we'll see what happens to the energy band. When we in the accumulation mode, the energy at near the, so this is the gate, the metal, oxide and semiconductor, and these are the conduction band, valence band and the Fermi level. So since it's a p-type semiconductor, the Fermi level is closer to the valence band. Okay, at near the surface, during the accumulation, your gate is now negative. The energy band will bend upwards. Okay, the conduction and the valence band will bend upwards. Fermi level doesn't change. It's always here, straight. These two will bend upwards. So when it bends upwards, we can see over here the difference between the valence and the Fermi level is smaller, which means you'll have more electrons, more holes here. So we call this the accumulation. Okay. Similarly, for the depletion, okay, when the depletion is when your gate voltage is positive, the energy band near the surface, okay, this region will bend downwards. Okay, for depletion, bend downwards. When it bend downwards, we can see the difference between the Fermi level, this point, and the valence is increasing. It's larger compared to here, which means it has less holes. Okay, if it is closer to the Fermi level, it will have more holes. So here it's less holes. It's called depletion. Okay. Now how about inversion layer? Inversion layer is similar to this because we are still applying positive, but it's bending a lot. It's bending so much that this difference becomes a lot. Okay, the hole to the Fermi level becomes a lot, but the conduction band gets very close to the Fermi level. So at this condition, this is a n-type semiconductor. Okay, over here it's p-type because the valence band is closer to Fermi, but over here the conduction band is closer to Fermi, so it becomes n-type, and we call it inverted. So this is the inversion mode. Okay, so these are the three modes and how the energy band changes. Okay, important thing is for accumulation it bends up, depletion it bends down, inversion it bends very much down. Okay, thank you.